In this tutorial, we are going to discuss how do you approximate the area or the volume of two-dimensional or three-dimensional objects. And the reason for understanding this technique comes is that in geometry, we have known variety of formulas such as formulas for cylinders, the volume of conics, or the areas of squares, trapezium, and so on, right? But a lot of times you will be given any shapes that will not make sense to apply any of those formulas because they will not resemble to any of those standard shapes, right? That is why we need to be able to find some approximation techniques that we can easily approximate the area or the volume of those given objects, okay? And one such example is right here in front of us, that we are required to calculate by approximation techniques the area of Manhattan, right? And Manhattan is the main island in the city of New York, okay? And we have been given this scale that 1 centimeter is equal to 3 kilometer. Well, for the purpose of this tutorial, we are not going to go into the details of how we got this scale, but we will just simply use it. Okay. Now, there could be multiple ways of how do you solve this problem. Okay. One way could be that you could divide this entire shape into its individual geometric sections. So let's say that this is a square right here, and then you have somewhat closer to a circle right above a square, right? This could be one technique, but you will be required to calculate the dimension of each one of those individually, and that could become tedious, right? So rather what we do is that we are going to discuss a different technique. It's a technique that is very commonly used in obtaining the area of any non-traditional shapes, okay? And this is called a grid technique. So what we do is that we position this map on a grid, such as the one you see right here in this diagram. And we say that the dimensions of squares in this grid are 1 centimeter each, right? So that means each square has a dimension of 1 centimeter of length or the width, okay? So in that case, the moment you place this grid on top of this area that you have to calculate, then you will find that by approximation, how many squares am I going to obtain, such as what you see here is that this is your one complete square that is filled by this, right? And likewise, you will say that, well, this specific square is filled only 3/4 of the total area, right? And this is right next to it is also filled approximately 3/4. And this specific square is filled only 2/3, and likewise this specific square too. And if you go to the top, I have this square filled only 1/4 and this square filled only 1/3. So this way you can at least find that how many squares are getting filled by this specific area that we want to calculate, and you simply obtain whether it is 1/3 or 1/4 or 1/2 and so on. You will obtain how much area of each square is getting taken by this shape that we have, and then you will simply obtain a summation of all of those areas. So that summation I could list down right here as shown here, that you will simply go from top to bottom that how much of the area of each square is being taken by this required area of the Manhattan, the main island of the New York City, right? So very first one is 1/3 here. So I got that. Then the second one is 1/4, which is right here. And likewise, you say that this one is 1/2 right here. So this is my 1/2. And likewise, you go from top to bottom to obtain how much of each square is being taken by this area that we want to calculate. And when you finally obtain a sum of all of those, you will find that sum of all of these fractions equals 8 squares, right? And we know that 1 square is equal to 3 kilometers times 3 kilometer, which is 9 kilometer square. So if I have 8 squares as you have obtained using this, then the total area will be equal to 8 times 9, and this is equal to 72 kilometer square. And you know what? The actual area of Manhattan is 59.1 kilometer square. Well, one could argue that the approximation gives you 72 kilometer square and the actual is 59. So our defense is that we are going to approximate, we are not going to obtain the exact area, right? So that is definitely an approximation, and 72 is not too far from the actual area, which is 59. So this technique would work more or less. We could further refine our argument based on that, well, this specific area is not necessarily 1/4, it may be less than 1/4. This is a section I'm talking about, right? So we could further refine our approximation as we practice more and more, but this is a technique that we use quite often in approximating the area of some non-traditional shapes using a grid square method. Now let's take a look at one more example in which we are going to estimate the volume of a three-dimensional object. So here is our second example, that we want to obtain a volume estimate of this bird sculpture that we want to make. And the reason we would like to have the estimation of volume is that so that we can gather that how much material is required, whether that is plastic or metal or whatever we are building this sculpture out of, okay? So the grid method will not work here because this is a 3D object. A grid method is good for obtaining the surface area, but when it comes to calculation of volumes estimate, we need to have a different technique, right? Because there are different thicknesses of this object at different places. This thickness at the beak will be very different compared to thickness at the body of this sculpture, right? So what we are going to do is that we are going to divide this entire object into its various elements. So beginning with the beak, you can say that the beak could be equated something like a cone, just like what we are highlighting this area, right? So this will be my area number 1, right? And when I come to body part, you can say that it is very much like a cylinder, such that you have an estimate of the radius at the top or the bottom, and then you know some idea about the height of this body, which is much like a cylinder, right? And then you can focus on the tail part. You will say that this is something equivalent to a equilateral triangle, but since it has a thickness, so it will be a triangular prism, right? So this is my area number 2, this is my object number 3 right here. And when you come down to the leg part, you will say that this can be equated to a cylinder, right? A very thin cylinder, right? Of course, once you know the radius of the base and the height, you can have some idea about the volume of the cylindrical section. And finally, when you get down to the foot part, you can say that, well, it could be equated to that of a rectangle with some thickness to it, okay? So let's list down all of these areas. So this is area number 4, this is area number 5. So this entire 3D object can be broken down into 5 components. Component 1 is a cone, right? For a cone, as long as you know the radius, the base, and the height of the cone, you can calculate its volume. And let's say this is volume 1. And then you go on to the body part, which is much like a cylinder, right? So you will say that with certain radius r and with certain height, you can calculate the volume of this cylinder. That will be volume 2, and so on. You will obtain the volume of this triangular prism with dimension of this equilateral triangle being a right here. So the height or the thickness of this will be h, and that will give you the volume estimate of the third object or the third part, right? And the fourth will be a cylinder again. In this cylinder, you will estimate what is the radius and the height of that cylinder to get to your volume number 4. And fifth is, of course, a rectangular prism, right? A rectangular prism with the dimensions being the length, the width, the height, and that will give you the volume estimate of the shape number 5. So the total estimated volume of this object will be basically a summation of all of these individual elements. So this is how you obtain the volume estimate of three-dimensional objects, okay? So this is where we pause, and our objective was to discuss how do you obtain the approximation of area of two-dimensional objects using the grid square method that we discussed, and the volume estimate you obtained was by breaking down a complex object into simpler geometric shapes. And after all, it is an approximation technique only for the purpose of estimation, right? So this is how you apply these approximation techniques in modeling of two-dimensional or three-dimensional objects.